amazing event. We've had some absolutely incredible projects here, and we are so excited to share the winners.
Okay, once again, Make Ohio is brought to you by OHIO and the Electronics Club. You can check us out at hack.osu.edu and electronicsclub.osu.edu. Also, another thank you to our sponsors for making the event possible: Microsoft, Honda, AEP, OHLA, and Cardinal Health.
And without further ado, let's just get right into it. So up first, we have our AEP representative to talk a little about the AEP challenge and their winners.
Hi, everybody. This is Matt Schellenberger with American Electric Power, and I'd like to thank everybody that participated in our challenge this year, and all the makers out there. So our challenge was related around renewable power and wind turbines specifically. So wind turbines are distributed, obviously, across a large area. If you sat into the kickoff that Chris did, so a lot of data that we want to collect out about those would be things like wind speed, wind direction, RPMs, damage on the blades over time, things like efficiency, vibration, temperature. Birds can be an issue, and that was well pointed out by one of our teams. And also, we provided a kit with lots of resources. Some folks used it, some did not, and lots of innovation from all 10 teams. So we'd really like to thank all 10 teams that took our challenge on, and everybody did a great job and provided lots of different takes on how to approach our challenge. So with that said, our number one prize, which is 4 $250 gift cards, goes to team number 1, which is Macaroni and Cheese, and their project was Macaroni Turbine. So with that, they did a very nice job. They well thought through their project. They added lots of sensors. They actually built some of their own sensors, which is to be applauded. That's quite a bit of a work to do in a 24-hour period. Let's see. With that said, we'd like to encourage all the teams to continue on with some of their projects. We had a quick meeting there after doing the judging, and we apologize to some of the teams. The judging got a little rushed there at the end, but we were able to at least watch all of your videos. And with that, that we saw in the videos, we'd like to encourage all of the folks to continue on with their projects and bring those to Show Ohio, which AEP is going to help sponsor, and we're going to be working on some additional prizes for those types of projects at Show Ohio. Also, we're going to continue with this challenge into the fall for the hack event, except what we'll be doing in those that particularly concentrated on the data management side of the challenge, we'll be actually providing some real world data from some wind turbines that you guys can process and make some additional use cases out of. So with that, that's all I have, and I appreciate everybody again doing the AEP challenge this year that took it on. Thanks.
Okay, thank you. And then next up is the Ohio Hotels and Lodging Association challenge. So the reps from that, if you guys want to start talking about your challenge.
Hello, everybody. I'm Ken Haney with OHLA and Red Roof. So our challenge, I'm probably, before I go into this, the least technical person on our Innovation and Technology Committee. So how I got the great opportunity to present here is beyond me, but I'm grateful. Our challenge, we had 2. Project 1 was to identify a repetitive task that could be automated as part of a housekeeping task. And project 2 was to identify a repetitive task that could be automated as part of a laundry attendant task. Now that I'm reading this again, I'm thinking we probably should have selected 2 winners. So if I could, committee, get back to you about that. So what we selected, our submissions were amazing, by the way. So all 3 teams, hats off, kudos to you. You did an amazing job. I think every one of these projects has use globally in the hospitality industry as far as automating tasks. we selected the robotic scrubber as the winner. For any of you who, and that was the team name on that. I don't have. I think it was number 38, the Ohioans. Congratulations to the Ohioans. What an amazing project that was. For any of you that have had the privilege of doing housekeeping in a hotel, it is the hardest task in a hotel, and it is the lowest paid in a hotel, and that's worldwide. So this project, automating something as backbreaking and strenuous as cleaning showers, is amazing, as well as the other two submissions, the automated laundry remover and the automated folder. So amazing projects. This isn't over for all three of the teams. I hope to have more dialogue with you all and see these projects come to actual fruition in reality. So thank you very much. Have a great weekend.
Right. Thank you so much once again. And last but not least, we have our Honda rep to talk a little bit about Honda.
Hey everybody, I'm Tony Fontana with Honda. We're really excited to be here at MakeOHI. We've done a bunch of OHIO events. I'm wearing my hackathon shirt, my MakeOHI shirt, so I need to get one for Make as well. But we wanted to say thank you so much for all the participants. I think this might be the most participants in the Honda Challenge that we've had at any event, any year we've been with OHIO. So yeah, thank you so much for that. I want to say if anybody is interested in learning more about Honda, to reach out to me at tfontana, Fontana at oh.hra.com. And I can put that in this chat if anybody wants to reach out and learn more about opportunities at Honda. I think we have some eyes on some people too, so we might want to reach out as well. But our project and challenge focuses on driver safety. So we're looking at what can people do with sensors or software to help improve driver safety even a little bit. We wanted some out of the box ideas, and I think we definitely got some. So I do want to pass it to Eddie to bestow the winners. We had first, second, and third place winners. So Eddie, please take it away.
Alrighty. First place, we have Uncle 5G and their automated seatbelt system and child safety system. In second place, we have the Luscious Bread Skewers with their flip car system. And in third place, we have Houston 6 with their automated distracted driving system, which pulls your car on the side of the road. We had 11 submissions, and we thank all of you for submitting it to the Honda Challenge, and we can't wait to see you next time. Thank you.
Okay, next up, we're going to do our general awards. So in fifth place is the Ohioans, and you guys get $150 Amazon gift cards. So yeah, good stuff.
And next up, rounding fourth place, we have, drum roll please, a cube. Woo! You guys each get some Apple AirPods 3rd gen.
And then in third place is the Fine Fellows, and you guys get Apple 4K TVs. So good stuff. And we're gonna play their video for you guys to watch.
Hi, I'm Colin. I'm an operations management major with an engineering science minor.
Hi, I'm Sylvia. I'm a mechanical engineering major.
Hi, I'm Isaac. I'm an electrical and computer engineering major.
Hi, I'm Pablo. I'm a history major with a business minor. We are the Fine Fellows. As part of the AEP challenge, we designed Blurbine, which is a sensor-to-web interface that gives you a real-time blurb on your wind turbine.
This is the Blurbine setup. We got a few things going on here. First, we have our wind vane to detect the direction of the wind. And as that changes, the wind turbine also rotates so that it aligns with the wind for more optimal output. The wind turbine's also decked out with a handful of sensors, and we get readings from those sensors live on our website. We got fan speed, current, internal and external temperature, humidity, wind direction, and turbine sound, all coming from sensors. And then we also have some machine learning to show us the predicted power output and the actual power output. And all of this is aggregated over time in this graph at the bottom. Now, if you were to add some sort of load to the fans, what you're gonna see over here is a transition from up to down. So that's letting us know that the wind turbine isn't operating as efficiently as it's supposed to be, and we need to do some sort of maintenance.
Here you can see we have our first sensor, the fan speed measurement. The way the sensor works is it has an infrared emitter and detector. When the fan blade passes in front of the emitter and detector, the light is reflected and received by the sensor. If the fan blade is not in front of the sensor, the light turns off. Using the change in time between fan blades, we can calculate the speed of the fan.
Behind our turbine, we have a little temperature sensor in here, and that's just to measure if like the internal temperature that the turbine is having inside of it. And then up here, rotating with it, we have a temperature and humidity sensor just to get like environmental data. And then we also have a sound sensor, and we can use that because depending on how the turbine's like vibrating, we'll have different sound measurements coming off of it. And then if we move back here again, weather vane thing and encoder. And so that's how we're able to move and control then our wind turbine. So we control our wind turbine with a stepper motor back in here. And we also have a Bluetooth module right here. And we use that Bluetooth module to send our data over to our website and our computer. And then we also are able to monitor the output current of the overall turbine just through some wiring. And I think that's all. Yes, we also 3D printed some parts and laser cut this box.
After we collect the data from our sensors using the Arduino, we use a Bluetooth module to send the data to this MATLAB script. This MATLAB script takes care of the plotting of the data. We also use MATLAB to create a machine learning model. We use this machine learning model to fix 6 regression parameters for our 6 input data, excluding the measured current. Using this input data, we construct the model to predict the output current. Comparing the true output current to the predicted output current can tell us if the wind turbine is functioning correctly or if it may be down and need repair.
We hope you enjoyed our project. Together we can make the world greener, one blurb at a time.
So once again, congratulations to Fine Fellows for winning 3rd place. And now to round off our awards, it's the time, it's what you've been waiting for. We will present our 2nd and 1st place awards here at MakeOHI 2022. 24 hours of working and 25 amazing projects. And so in 2nd place, we are proud to present Mediocre Amateurs, and all you guys will win a Nintendo Switch OLED. Round of applause for them.
And here is their project video.
This is our project. We did the AEP challenge, and the main thing we were focusing on in the beginning was trying to get fan speed. And so we used a laser and a photo transistor right here. And we covered this with electrical tape so it wouldn't get interference from things that weren't the laser. Then if you look closely, the fan has different colors on different blades, and these correspond to different reflectivities, which make the phototransistor receive different light intensities. So you can actually tell which fan blade is moving past the phototransistor at what time. And we use that to calculate not only the fan speed and rotations per second, but also the if there is any imbalance, because you can detect the difference if a certain blade is going slower as it goes up than the other blades are going, and that will tell you the imbalance.
So some other sensors that we have are, this is a temperature and humidity sensor. So just measuring the ambient temperature and humidity. We also have this right here is an accelerometer and a gyroscope that is taped to the fan. So we're using that to measure vibration and see if there is any extra vibration that's going on. And we also are measuring power. And the way that we're doing that is we've split the wire. We attach it to the breadboard. We have 4 resistors that are in parallel, and we're measuring the voltage change. And then we used Ohm's law to calculate the current. And then we used current and voltage to calculate the power.
Yeah, and one thing we know is that the output of the computer is 5 volts. So if you do 5 volts minus the voltage change over the resistors, you get the voltage through the fan. And then you know the current is the same because it's in series with the resistors.
Yeah. And then one thing to tie it all together, we made a little app so you could track all the data. So it connects via Bluetooth. This is the Bluetooth module right here. So I will turn on. So I connect to Bluetooth. It's the HC06 module. And we're connected. So we can see temperature right here. We can see humidity. Accelerometer is at 0 because it's not moving past regular vibrations. Here's the tachometer. It's not perfectly calibrated at the moment. And then here's power. And then and something that we added was if the fan was to move too much due to certain vibrations, the accelerometer would pick that up. And okay, well, it's not super sensitive, I guess. But something that we did do is if the fan speed goes down and we know that there's power being output, an error will be thrown because it's trying to receive power, but it can't, or it's not able to spin. So we'll get a no spin error, check the turbine, that kind of thing. So you have to dismiss it. So yeah, the app is just to bring everything together and track data a lot easier.
And now to present our
first place winners,
we have
Runtime!
Woo! Congratulations, guys.
Yeah, Microsoft Surface headphones.
And to round it all out, let's watch their project video.
Hello everyone, we are Team Runtime and our project for today is a refreshable braille pad. In the United States, over 12 million have vision impairment, with around 1 million of them being completely blind. The CDC approximates that this number will nearly double by the year 2050. One of the major drawbacks of existing and traditional braille materials are the paper space requirements and the bulk of braille books, the limited and slower scanning strategies for accessing information, and difficulties with tools for reading and writing, which has raised concerns over literacy for blind people in the United States. Currently, the price of braille displays range from $3,000 to $15,000 depending on the number of braille characters displayed. By braille displays, we mean refreshable braille pads, which are smaller alternatives to large braille books. We aim to solve this problem by providing a low-cost and easily accessible alternative to this. Our project involves a 3D printed enclosure with pins that vibrate in a pattern corresponding to the braille for the alphabet or word that is being read. By being read, we are taking an image or a scanned piece of text, running that through a conversion that then gives us the corresponding braille. Braille works in 2 forms, in a 6 and an 8 grid array. We have opted to go for the 8 grid array as it is more complex and provides access to a greater number of characters, thus improving the learning rate. We have also added in a similar grid of LEDs as it is difficult to demonstrate the vibration of the pins in this video. You can see the LEDs light up corresponding to the Braille pattern. The article being read out is actually a survey of Facebook research that states, in this section, we summarize the themes and findings of research that emerged from our review of the literature. You can pause this video and compare what I have just said to the Braille text we are putting up on screen. You can see how a device like this can provide access to even complex research articles and assist the visually impaired. Now on to some of the challenges we've faced, starting with the image and character recognition. The biggest problem that we ran into was when the background is a colored pattern. Our characters were not recognized correctly, leading to inconsistencies in the Braille pattern displayed. Another one of the major challenges was 3D printing the actual enclosure. Our initial idea was to have the pins move up and down, much like existing refreshable Braille displays. However, with inconsistencies in 3D printing, this idea was modified to be vibrating pins. We believe this is a trivial problem, as on scale with 3D printers that have been well calibrated, this issue can be easily solved. After all, Runtime strongly believes that the world only progresses when nobody is left behind, and we aim to do just that. Thank you for your consideration and your time.
Questions to Runtime.
And we also want to say congratulations to all the teams who came here and participated. You guys were all awesome. And so just some final announcements before we go. If your team won something, your prizes will be shipped to you. So just keep an eye on your email from something from OHIO, and we'll get that to you.
Also, Show Ohio will be on April 8th, so you can present your projects at Show Ohio. It's our showcase event, and you can apply to present at go.osu.edu/ShowOhio2022.
And just one last thing, we want to say a big thank you to Innovation Studio and eClub for helping us create this absolutely amazing event. Round of applause for those guys. They're absolutely amazing.
And thank you to our participants for making something amazing.
And with that, we want to officially close out Make Ohio 2022. Thank you everyone for coming.